Welcome back. How did you do in this exercise? Were you successful? Were you not? Here's the thing. This is actually extremely simple, but it looks overly complex. And that's a general trend with graphs. They look really intimidating at first and really hard to really think about them in your mind. But once you put things down, understand things, maybe draw things out, they're actually quite simple. And they're very similar to what we've learned up until now. Everything we've learned about hash tables, arrays, trees, linked lists are all part of graphs. And graphs simply use those data structures. For those of you that weren't able to solve this problem, it might be because you were a little bit intimidated as to the task at hand. But let me show you how simple this can be. In order to add a vertex to our adjacency list, all we need to do is to simply say this.add, or this adjacency list is going to have node. So we're adding the key into this object of the node that we want to add, and that's going to equal an empty array. Because when we enter a new node, it's not going to have any connections initially. We want to add the edges afterwards. And then finally, we want to increase the number of nodes by 1. Now we have one more. That's it. We've just created our nodes. Look at that. We have 0 all the way through 6, and they are in our graph. Unfortunately, none of them connect to anything. We've just created the nodes, but none of the edges. So let's go ahead and do that. With the edges, because this is an undirected graph, what we'll have to do is say this dot adjacent list is going to say node 1, that is the first node that we're giving. And the node 1 is going to push. Remember, this is an object, so we're getting the key. So that is, let's say this is node 0. It's going to push to the array of connections that node 0 has and say that it's going to be connected to node 2. And because this is undirected, that means we have to do it the other way around as well. So we simply copy this. Let's make this a little bit bigger so you can see. And we simply reverse things. So node 2 is also connected to node 1. If I press run here, look at that. We have our graph. How simple was that? That wasn't bad, right? And I mean, we could create this in a linked list if we wanted to, but the concept is the same. If we look at 0, that is connected to 1 and 2, we can confirm that 0 is connected to 1 and 2. If we look at 1, 3, 2, 0, 1 is connected to 3, 2, 0. And let's check maybe 5, which is connected to 4, 6. 5 is connected to 4, 6. And there it is. We've just created our very first graph. When it comes to interviews, graphs aren't as big of a topic as the other data structures, mostly because they take a bit of time. And questions regarding graphs can be overly complex. That doesn't mean that you won't see them, but they are rare. However, by knowing the basic fundamentals, what types of graphs we have, and how you might create graphs, how you might want to hold data in graphs, such as adjacency matrix, adjacency list, and edge list, you already show that you have the ability to understand graphs, which is an advanced concept. Now, because graph questions aren't that big a part of interviews, we won't be spending any more coding time on it. But also keep in mind that we have a section coming up on algorithms where we're going to dive a little bit deeper into things such as breadth first search and depth first search, which can be applied both to graphs and trees. So if you feel like you can still learn a bit about graphs, don't worry, we're still getting there. But for now, congratulations on creating your first graph. I'll see you in the next video. Bye-bye.